look at Newton's third law of motion, which is the law of action and reaction, which is also called the law of momentum. We're looking at collisions and how every action is going to cause an equal and opposite reaction. There is a law of the conservation of momentum that states that the momentum before the collision is equal to the momentum after the collision. And remember, momentum is really just mass in motion. If a cue ball, let's say, hits an 8 ball directly, that's a collision. So there is the action is the force the cue ball has on the 8 ball, and then the reaction is the force the 8 ball has on the cue ball. And they're equal to each other. So the force is equal in magnitude, and it happens at the same time. So same time, same amount of force in a collision. So the action and reaction have the same magnitude of force, and they happen at the same time. So I know I mentioned think of it as cause and effect, but it really is not exactly the same as cause and effect, because in reality cause happens before the effect. In this case, the action and reaction happen at the same time. Okay, when I hit this cue ball, that is a collision. Okay, so this cue stick is when I hit it, it's providing a force going this direction. That is the action. So the action force. The cue ball also applies a force going the opposite direction. That's the reaction. So that's one collision. Then when I hit this cue ball, it's going to hit this 8 ball. And this is a second collision. So we're going to look at the second collision here. So I'm going to look at the action and reaction with this cue ball and 8 ball. So we're going to look at this now. So cue ball, the white one, is going to go this direction. It's going to hit the 8 ball, and that's a force going to the 8 ball. However, the 8 ball applies an equal and opposite force toward the cue ball. So the force from the 8 ball is going to go this way. Same amount of force happening at the same time. Now, there is a law of the conservation of momentum that states that momentum, remember, which is mass in motion, or mass times velocity, it states that momentum before the collision is going to equal the momentum after the collision. So remember, the collision is like the crash. So if the 8 ball is hit directly with the cue ball is going to stop, and the 8 ball will roll with as much momentum as the cue ball had before the collision. So that is if this cue ball hits the 8 ball, and if the cue ball stops completely, the 8 ball is going to roll with the same amount of momentum the cue ball had before the collision. That is the law of conservation of momentum. Since the masses of the 2 balls are the same, this means that the 8 ball will have the same velocity that the cue ball had. All right, so these are the same. We're going to say these are the same mass. So the 8 ball is going to, if this cue ball stops, once it hits the 8 ball, that 8 ball then is going to have the same velocity as the cue ball because their mass is the same. If the 8 ball is hit on the side, so if I want to hit the 8 ball over here because maybe I want to get it into this corner pocket, the 2 balls will roll in different directions. Okay, because so if I hit this ball on the 8 ball on the side, the 8 ball is going to go that way, right? And then the cue ball is going to go this way. So they're going to go opposite directions. But the total combined momentum is going to equal that in which the cue ball had before the collision. So in other words, even though both balls are moving, they're going to move at a slower speed than the cue ball was moving by itself because the cue ball has transferred some of its momentum to the 8 ball. Okay. So now I'm going to hit the 8 ball from the side. Oh.